So in the last class we were talking about circular motion, right? And I just want to talk about a couple of other terms used in circular motion. Angular displacement you already know. Angular velocity you already know. Angular acceleration you already know. Right? And maybe you know this one still. Capital T. Capital T is called the time period. And time period is the time for one revolution. And it is equal to very good, 2 pi by omega. 2 pi एंगल रोटेट करने के लिए कितना टाइम लगेगा? Distance upon velocity, or in this case angle upon angular velocity. Angle that we have to rotate is 2 pi, angular velocity is omega. Okay, and then we have F, which is frequency, and this is equal to the number of revolutions per unit time. ये time period का उल्टा है. Time period is the time for one revolution, and frequency is number of revolutions per unit time. So F is equal to 1 upon T, or it is equal to omega by 2 pi, or we can say that omega is equal to 2 pi F. So these are some relations that we will be seeing again and again and again and again in physics. So it is better that you are comfortable with these things. Very simple, very logical. इसमें कोई कॉम्प्लिकेशन नहीं है. टाइम फॉर वन रेवोल्यूशन, अगर कोई चीज गोल गोल घूम रही है तो भाई यहाँ एक चक्कर कितना टाइम में लिया उसने, एंड एक सेकंड में कितने चक्कर ले रहा है. That is what we need to know. Okay, so we were discussing mechanics of circular motion, right? We were discussing how to deal with circular motion in mechanics, right? And I would like to take that forward now by giving you a couple of questions. हाँ पार्थ पूछो, इसमें डाउट है. अनम्यूट कर दूं तेरे को. हाँ WhatsApp. So first question that I want you to do, something you can try out also at home. It's very easy. So we have a string of length L, and it is fixed at this point O, and the other end of the string has a particle of mass, has a point particle of mass n. So one end of a point particle of mass m. Okay. Now, the system rotates as shown. Okay. So, part A. If angular velocity is omega naught, then find the tension in the string B. If it's going to part है and the angle theta B. Theta is equal to 30 degrees. Find the time period T चलो ये वाले दो क्वेश्चन प्लीज स्टार्ट इसका स्क्रीनशॉट ले लो पलक हो गया स्क्रीनशॉट ले लिया जो क्वांटिटीज गिवन है उसी के टर्म्स में निकालना है ना, बाकी सारी क्वांटिटीज should you should be able to work it out. So what did I tell you? First, recognize the circle. Okay? And in this question, I have already given you the red circle. That is the circle along which the particle is moving. अब answer छोड़ो, पहले मेरे answer my questions. I'm going to ask some questions. Please answer them. So the first step is to identify the circle which I have. It is the red circle. Okay. The second step, or actually the first according to what we discussed last time, is that wherever the particle is, that should be the origin. Okay. So the particle is here, wherever it is shown, that is the origin. And now I have to draw three axes, right? Sorry, two axes, tangential axis and the radial axis. Okay. Tangential किधर है और radial किधर है? Where is the radial axis? Where is the radial axis? The radial axis is this one. Right, remember, the radial axis will pass through the center of the circle. Where is the tangential axis? Can anybody answer this? Where is the tangential axis? Where is the tangential axis? Where is the tangential axis? Good, yes. So I cannot draw the tangential axis here. Very good, yes. I cannot draw the tangential axis because it is perpendicular to the screen. Okay. And there is a third axis as well, right? I think I forgot about this in the last class. So please, in your notes, add this. There will be a third axis as well. Okay? In this case, the third axis is here. So this is the radial axis. This is the third axis. And the tangential axis I cannot draw. Okay, and the third axis does not have a name. That's why I'm calling it the third axis. सोनल, मेरे पास 3D पेन नहीं है ना, इसलिए मैं नहीं बना सकता. 3D पेन होता तो मैं बना सकता था. Tangential axis is out of the plane of the tab screen. So once we have, please update this in your notes if you have not already written. यहाँ पे हमने लिखा था draw the radial and tangential axis. वहाँ पे लिखना है draw the radial, tangential and third axis. Okay, the third axis is literally the third axis. जो radial और tangential जब आप identify कर लोगे तो जो तीसरी direction बचेगी, that will be the direction of the third axis. Now, in any problem, what is going to happen is that you are going to be able to draw only two axes for all practical purposes. केवल दो axis आप बना पाएंगे, तीसरी नहीं बना पाएंगे. जैसे यहाँ पे मैं tangential axis नहीं बना पा रहा हूँ, right? Because it is out of the plane. Okay? We generally make two-dimensional diagrams. Therefore, out of these three, tangential, radial, and third, we will be able to draw two axes only, right? In very rare cases, you will have forces which will be along the three dimensions, and in that case, you'll have to do some extra work and draw a couple of diagrams. इधर से देखूंगा तो ये दो एक्सिस दिखाई देगी, उधर से देखूंगा तो ये दो एक्सिस. But it will be very rare, so you don't really have to bother about it. You don't really have to remember this. Okay, so once you have drawn the axis, then you're supposed to draw the FBD. So mg is acting like this, tension T is acting like this, and this is angle theta, right? alternate angle radius. So the component of forces, components of forces, I'll have to find for T. This will be T cosine theta, and this will be T sine theta. Right? Now, once you have made the FBD and you have found the components of all the forces along your drawn axis, then you are supposed to write down three equations, right? And this I will write down separately as well, because this is what really is important. This is what you need to remember. Summation of forces along the radial axis will be equal to mass into radial acceleration, and radial acceleration is v square by r. Okay, radial, remember, is another word for centripetal. So this can also be written as m into omega square, sorry, m into omega square r. उसके बाद से summation of f along the tangential axis must be 0. Summation of force along the third axis must also be 0. Right? This is for uniform circular motion. This is for uniform circular motion. We will discuss non-uniform circular motion, and in that case, this condition will not be true. There will be something else here. But बाकी दो हमेशा, सारे circular motions के लिए बाकी दो हमेशा true रहते हैं. Okay? We need to remember this. So let's go back to this. देखो, थर्ड एक्सिस में ऊपर फोर्स टी कॉस थीटा है, नीचे एमजी है. रेडियल एक्सिस में टुवर्ड्स द सेंटर एक ही फोर्स है, टी साइन थीटा. सो फोर्स टुवर्ड्स द सेंटर minus force away from the center. There is no force away from the center here. So force towards the center is equal to m into radial acceleration, which is equal to omega naught square r. Right? Now Radhika was asking r कहाँ से निकाले, r कितना है? But अगर आपको r मैंने परोस के नहीं दिया, if I have not said that this is, look, this is the radius, then it is guaranteed that somewhere it is hidden. Okay? Somewhere I have given you r, but not directly. Good. Yes. Very nice. Very good. So, I told you, remember, बहुत पहले I told you that our best friend is going to be a right angle triangle. Always be on the lookout for right angle triangle. So the radius is equal to L sine theta. So basically I get T sine theta is equal to m omega naught square L sine theta, right? And this cancels out, and I get the first answer. T is equal to m omega naught square L. Okay, then for the third axis, I get T cosine theta is equal to mg, and this tells me that cosine theta is equal to mg over t, but t I have already found is equal to m omega naught square L. So m cancels out, and I get cosine theta is equal to g upon omega naught square L. So I found theta as well. Right? And then they say that in the second part, they say that if theta is equal to 30 degrees, then find the time period. इसका मतलब कि अब ये ओमेगा नॉट से नहीं मूव कर रहा है, अब ये किसी और ओमेगा से मूव कर रहा है, लेकिन अब मेरे को थीटा की वैल्यू दी हुई है 30 डिग्री. This is also very, very easy, extremely easy. If theta is 30 degrees, I'll just go to the next page. Please take a snapshot of this page. Everybody, please take a snapshot. ये टैप पकड़ के हाथ में दर्द होने लग जाता है. So if cos theta, so cos theta is equal to g by omega naught square L, then I get cos theta is equal to g by, now omega, remember, omega is equal to 2 pi upon t. So this implies that t is equal to 2 pi by omega. This was the original relationship that I told you. So g upon 4 pi square L t square. So t is equal to 4 pi square L cosine theta divided by g. Therefore t must be this. So t must be equal to 2 pi root of L cosine theta. Cosine theta 30 degrees. So this should be equal to root 3L by 2g. ये फॉर्मूला किसी को याद आ रहा है कहीं से? कुछ ऐसा देखा दिखाया फॉर्मूला है किसी के पास? आई वंडर. हाँ, कहाँ देखा था पार्थ इसको? क्या है ये? वेरी गुड अभिजीत. यस यस यस. I think somewhere or the other somebody would have told you time period of a pendulum. Yeah. Yes, yes. Time period of a pendulum. I think कहीं ना कहीं सामने आया होगा या तो 10th क्लास में या 11th क्लास में. T is equal to 2 pi root L by G. Okay. So this thing is called a conical pendulum. Therefore, the time period formula is somewhat similar. Not exactly similar, but somewhat similar. So this guy is called a conical pendulum. Can you guess why it is called a conical pendulum? Can you guess why the word conical must be used? Can you see? Can you just look and tell why the word conical must be used? Good. Yes, because yes. Because the string, the black string that I have drawn, as this particle moves along the red circle, the black string will trace out the surface of a cone. Right? Will trace out the surface of a cone. That's why it's known as a conical pendulum. Okay. Good. ये कुछ कुछ समझ में आ रहा है भाई सब लोग को? कुछ कुछ थोड़ा बहुत? Question number 2. Question number 2. block of mass 1 kilogram is attached to रुक जाओ पार्थ two strings of lengths 3 meters and 4 meters. The system is rotated as shown. ये 3 मीटर है और ये 4 मीटर है. A. Find omega if the difference in tension of the two strings is 100. चलिए करिए. Do part A and then I'll give you part B. इसमें I think हो गया. लास्ट स्लाइड का काम हो गया. इसमें I'll have to give you the हाँ नहीं सही है. क्या पूछ रहा है साहब? वैसे भी गंदा सा आंसर है। ओनली वन, और कोई नहीं। हाँ करो करो, आराम से करो। तो पहले where is the circle? And the circle must be here. This. Then the FBD, there will be some tension here. There will be some tension here. And there will be an MG here. I hope everybody has ये सबने बनाया. Now what do you do? Where is the radial axis? Can I draw it or not? Yes or no? Can I draw the radial axis or not? Can I draw the tangential axis? Very good, yes. नहीं अभी tangential axis नहीं बना पाएंगे. सर्कल को देखो ना, मैंने सर्कल जो बनाया है रेड से, मैंने उसको टेढ़ा बनाया ना, फ्लैट नहीं बनाया ना मैंने. थर्ड एक्सिस बनाओ, सारे फोर्सेस का कंपोनेंट निकालो. सारे फोर्सेस का कंपोनेंट निकालो पार. Equate the radial forces to m omega square r. But what is r? Very good. Yes, very good, Radhika. Yes. Yes, बहुत बढ़िया. Yes, r is 12/5. Yes. फिर आगे अब क्या करें? अब क्या करें? हाँ, मतलब सब राइट एंगल ट्रायंगल्स में वहीं पे सब दिखाई दे रहा है ना हमको. आई होप. तो ये वाला एंगल क्या होना चाहिए? ये वाला एंगल क्या होना चाहिए? This angle should be 53 degrees. Yeah. And this angle should be 37 degrees. Now, Zoeb was asking कि green line क्या है? मैं actually radius बना रहा था. This angle will be 37 degrees. This angle will be 53 degrees. Yes, yes. Oops. एक मिनट रुको. So I want to draw this separately. We have T1, T2, mg, यहाँ पे क्या आएगा, T1 sin 37 degrees, T1 cosine 37 degrees, T2 cosine 53 degrees, T2 sine 53 degrees. Right? So we have for the radial axis, remember that this is the radial direction, this is radial axis, this is the third axis. 9 आ रहा है क्या, ये देखते हैं, लेट्स वर्क इट आउट. रेडियल एक्सिस में हमारे पास जो इक्वेशन आएगी वो आएगी T1 कोसाइन, अब मैं कोसाइन साइन नहीं लिखना चाह रहा हूँ, मेरे पास आएगा 4T1/5 प्लस 3T2/5 is equal to m into omega square into r, which is 12/5. r में किसी को प्रॉब्लम नहीं है ना, रेडियस में, रेडियस 12/5 आएगा. So we get this one relation. उसके बाद से मैंने क्वेश्चन थोड़ा सा गड़बड़ कर दिया क्या, सॉरी सॉरी, I don't think we need this. ये इसकी जरूरत ही नहीं है. Find omega. So third axis में आएगा मेरे पास T1 sin 37, that is 3T1/5 is equal to, नहीं मैंने वो एक मिनट हो गया, दिमाग नहीं काम कर रहा. हाँ तो हाँ चाहिए, हाँ बिल्कुल. थर्ड एक्सिस में we will get 3T1/5 is equal to mg, that is 10, plus 4T2/5. Right? Multiply throughout by 5, you will get 3T1 is equal to 50 plus 20T2. Right? And it is given from here 4T2, sorry. And it is given from here that T1 minus T2 is equal to 100. Now I put a mod sign here because I don't know which one is greater. Okay? I can only guess कि ऊपर वाला बड़ा होना चाहिए. Now using these three equations, calculate T1, T2 and omega. अभी राधिका समझ में आया, नेगेटिव नहीं आएगा क्योंकि उसमें मॉड लेना है हमें. हाँ बिल्कुल सही. T1 की वैल्यू डाल दो 100 प्लस T2 ऊपर, तो 100 प्लस T2 डालेंगे तो हमारे पास आएगा 300 plus 3T2 is equal to 50 plus 4T2. That would mean that T2 is equal to 250. And if T2 is equal to 250, you can find out T1. And once you know T1 and T2, you can put it in the radial wala equation and find omega. तो पार्थ आंसर मुझे नहीं मालूम है भाई, आप वर्कआउट करो ना इसमें। मैंने तो you want me to work it out? I can do it, but T2 is equal to 250 Newton. 250 यहाँ डालेंगे तो 250 into 4 is 1000. 1050 divided by 3 is T1. 1050 divided by 3 parts. So 1050 divided by 3. 3 threes are 350. Now omega is equal to root of 4T1 plus 3T2 divided by 12. हाँ भाई पार्थ, ये कर लोगे, हो जाएगा ये। अरे क्या कर रही है राधिका? यहाँ से हमारे पास आएगा T1 is equal to 100 plus T2. ये 100 plus T2 यहाँ डाल दो। आया समझ में राधिका? विश्वजीत, अब T2 आप ग्रेटर क्यों लोगे, मुझे नहीं समझ में आ रहा है। करने के लिए तो हम इसको जो है क्वेश्चन करने के लिए हम सर के बल भी खड़े होके कर सकते हैं, नहीं उल्टा होके कर सकते हैं, बट ऐसा करते नहीं है ना। T1 ऊपर का टेंशन है ना। It must not only balance T2 but it must also balance mg, so T1 must be greater than T2. In any case मैंने वहाँ पे mod लगाया हुआ है। If you take T2 greater than T1, you will get some negative quantity, so you will know that it is wrong. Okay, next. Screenshot ले लीजिए please. Remember that this is the first equation, this is the second equation, this is the third equation. Okay. A circular track is banked at angle theta. Anybody know the meaning of this? Anybody? Ah, good. Yes, Parth. Yes, Abhijit. Good. सबने साइकिल रेसिंग देखी है? इंडोर वाला साइकिल बाइसिकल रेसिंग देखा है? इंडोर वाला? हाँ बेन, बिल्कुल सही। इंडोर बाइसिकल रेसिंग। यस तनिषा। इंडोर बाइसिकल रेसिंग में जो, अगर आपने नहीं देखा है तो यूट्यूब पे यू कैन सी, तो उसमें जो ट्रैक होता है that is inclined, it is not flat. Okay, and I don't think I can draw that diagram. I've been drawing for 20 साल से मैं कोशिश कर रहा हूँ ये बनाने का, but बनता नहीं है कभी मुझसे. So the track itself is circular, but it is inclined. So this thing is inclined. This thing is inclined. ऐसे. अगर हम साइड से देखेंगे तो हमको ट्रैक ऐसा दिखाई देगा. और this is a part of a circle like this, and it is this angle which is theta. Right. So I'll give you two examples of this. The first was the indoor bicycle racing track. The second example is that if you've ever been on a road in the mountains, so the road in the mountains is such that it will go for some time in a straight fashion, and then there will be something called a hairpin bend. Right? तो रोड बनाने का तरीका वही होता है माउंटेन्स में कि उसको रोड जो है वो it goes like this, and then there is a hairpin bend, then it goes like this, then there is another hairpin bend, it goes like this. So if you have been on this portion, you will see, or you would have seen, that the road on the farther side, the road on the cliff side, is uh, lifted up as compared to the road or the portion of the road on the inner side. That is called banking. That is called banking. A circular track is banked at an angle of theta, and a particle travels on this track at a radius r. Find its velocity. Right now, however weird the question may seem to you, please don't worry about it. Please do what I have told you to do. Location of the particle is the origin. Try to draw the radial, tangential, and the third axis. Try to draw the FBD. Find the components. Forces towards the center minus forces away from the center will be equal to mv square by r, or m omega square r. Forces along the tangential axis or the third axis will add up to 0. हाँ बिल्कुल सही, yes. बिल्कुल सही. Yes, very good. Yes, yes. Okay. So this is not very difficult. This is actually very easy. This is the बोलना है प्रसन्ना. This is the radial axis. This is the third axis. I'll just write it down. This is the radial axis. This is the third axis. Okay. Right. Now, what are the forces acting on this? Well, the forces acting on this are normal reaction N and mg. Right. So why am I giving you this question? Well, I wanted to show you that the centripetal force can also be normal reaction. This is n cos theta and this is n sin theta. You see, it is the component of normal reaction along the radial axis which is responsible for the circular motion of this object. So we get n sine theta is equal to mv square by r. N cos theta is equal to mg. Just divide and you get tan theta is equal to v square by rg. Right? We'll use this many times. V is equal to root rg tan theta. देख लो स्मिथ आपका आंसर सही है या नहीं. You can compare and you can tell me. Okay. Next part of the same question. If the coefficient of friction is mu, then find the range of velocities with which the particle can travel or move without slipping. Okay, and mu is definitely less than tan theta. Smith, याद नहीं रखना है ना कुछ भी. I'm not asking you to remember anything. हाँ, सब लोग आंसर tan के टर्म्स में क्यों दे रहे हैं? पुराना फॉर्मूला तो नहीं इसमें? नहीं, गलत है। हाँ अभिजीत, गुड। हाँ, so I'm going to change the page for this. So you remember how we did the range of velocities वाले questions? All you have to do, हाँ सही निकाला समझ। All you have to do is when drawing the free body diagram and mg, एक बार आपको यहाँ पे फ्रिक्शन को म्यू एन लेना है और एक बार नीचे में फ्रिक्शन को म्यू एन लेना है। एक्सेस तो वही रहेगी हमारी, ये हमारी रेडियल एक्सेस है और ये थर्ड एक्सेस है। And we know that this angle is theta, we know that this angle is theta. So this is mu n cosine theta. And here we will get mu n sine theta. Here we will get n cosine theta. Here we will get n sine theta. And here, of course, mg is there. So along the radial direction, force towards the center minus force away from the center, right, is equal to mv square by r. And third axis के along, ऊपर वाला force mu n sin theta plus n cos theta is equal to mg. So n is equal to mg upon mu sin theta plus cosine theta, right? And from here we get v is equal to under root of r by m into sine theta minus mu cos theta into n. But n is equal to mg upon cosine theta plus mu sine, right? This must be v minimum. What should I do for v maximum? क्या करना चाहिए v maximum के लिए? इसको मैं यहाँ पे बना दे रहा हूँ, but I will not तो यहाँ पे आएगा n और mg और यहाँ पे आएगा, हाँ बस फ्रिक्शन का डायरेक्शन रिवर्स करना, बाकी सब कुछ सेम है। ये रेडियल एक्सिस है, थर्ड एक्सिस, mg मैंने थोड़ा सा टेढ़ा बना दिया, which I should not, There should be no confusion here. Mg is here. Okay, and then again you find the components into the same thing, and you get the value of V. Okay, okay. I think I will stop here. से आगे मैं नहीं जाऊंगा. I hope आप लोगों ने HCV शुरू कर दिया है. HCV में जहाँ जहाँ पे यूनिफॉर्म सर्कुलर मोशन लिखा हुआ है that you have to do, and this is absolutely new to you. ये आपने 10th में कभी नहीं टच किया है. बस टर्म्स सुने होंगे, सेंट्रीपिटल, सेंट्रीफ्यूगल, बट करना है सोनल, अभी नहीं, आराम आराम, पहले ये तो समझ जाओ. नॉन यूनिफॉर्म सर्कुलर मोशन करना है, बिल्कुल करना है. So this is completely different from class 10th, right? अरे जोहेब देख लो ना, उसकी वैल्यू जो ज़्यादा, अगर वेलोसिटी मिनिमम होएगी तो उससे कम कर देंगे तो नीचे स्लिप कर जाएगा ना. फ्रिक्शन ऊपर होना चाहिए. मोशन इन वर्टिकल सर्कल पार्ट हम वर्क एनर्जी में करते हैं, अभी नहीं करते हैं. ठीक है. मोशन इन वर्टिकल सर्कल के क्वेश्चंस हम वर्क पावर एनर्जी जब पढ़ेंगे तब मैं आपको बताऊंगा कैसे करना है, अभी नहीं. ओके, सो ये सर्कुलर मोशन, यूनिफॉर्म सर्कुलर मोशन का टॉपिक खत्म. नेक्स्ट क्लास में हम नॉन यूनिफॉर्म सर्कुलर मोशन करेंगे, और उसके नेक्स्ट क्लास में हम सेंट्रीफ्यूगल फोर्सेस करेंगे, राइट. स्यूडो फोर्सेस इन रोटेटिंग फ्रेम्स करेंगे, और ये चैप्टर हमारा खत्म हो जाएगा. एक बार ये चैप्टर खत्म हो जाएगा, देन विल डू वर्क पावर एंड एनर्जी. चलो, आई विल सी यू in the next class.